Welcome back to Calculus with Ansari. Today we're going to discuss limits a little bit more in detail. Now, limits definitely have a confusing notation. It looks extremely weird. Like we write words out with like X's under it, arrows, numbers, etc. Now, there's also an addition to this notation, as if it wasn't confusing enough. There's another addition to this. So usually we're used to the idea of just the limit as x. There's an arrow and there's some number here and some function. And what this means is the limit as x approaches a from both sides. And what I mean by that is if I have some sort of function, I don't know. Let's make some function that looks like this. Let's say we want to figure out the limit. This is a. So we want to figure out the limit as x goes to a of f of x. What this notation is denoting is that what is the limit, or what does the function approach as x goes to a from the left side and from the right side. Okay, so this is actually interesting. So, so basically what we need to say is that the limit needs to be equal, reaching it from the left and reaching it from the right for this limit to exist. So in this case, the limit as x goes to a from the left and right are both equal. So the limit we'll just say is b. In this case, we'll define that point to be b, so this is equal to b. Now, this gets interesting when the function actually doesn't reach the same value from both sides. So let me define another function. Let's draw our axes. We have our y-axis and our x-axis. And let me think of a function that I don't know. I'm just going to arbitrarily define a function that looks like this, and then that looks like that. Okay, so this is the same function, which is there's a discontinuity here, right? Now, for this function is interesting. Let's say this value here is a as well, and then this value is b, and then this is 0, obviously, right here. Okay, so for this function, we cannot say that the limit as x goes to a is equal to b. Sorry, let's call this function g of x. So the limit as x goes to a of g of x is not equal to b, because from the left side, if we approach it from the left side, if we approach this point from the left side, we notice that we reach b, right? The limit goes to b, so that's true. But as we come from the right side, so here, let me denote it with a different color. As we approach it from this side, we notice that we actually approach something else, and that something else in this case is 0, right? We approach 0. So, b is not equal to 0. So this seems like it has two different limits. So for that reason, we cannot say the limit as x goes to a of g of x is equal to b. However, we could say, so this is where the new notation comes. We could say that the limit as x goes to a from the positive side, so that's usually denoted with the positive side right there, a positive sign right there, of g of x is equal to a certain value. And what this means is the limit as x goes to a from the positive, well, as we approach a from the positive, we are approaching 0. So this is equal to 0. This limit does exist. And then we can separately say that the limit as x goes to a from the negative side of g of x, well, if we come from the negative side, that means from the left, we're going like this, we approach b. So this is equal to b. And these limits exist by themselves. And if these two values are different, then the limit as x goes to a from both sides, like when we don't write the plus and minus here, this just means from both sides, of g of x is non-existent or does not exist. So this is the new notation that I wanted to introduce in this video. You can define the limit to just be from the left or the limit to just be from the right. And if they're equal, then you can just say, x as x goes to a, there's the same value. If they're not equal, you can only define the limits by themselves. And yeah, so I will talk to you next video.